Welcome to Explaquiz channel. In this video, we'll trace the history of Python and see how it grew from a small project in the late 1980s into one of the world's most popular programming languages. We'll also pause for quizzes along the way, so you can check your understanding of the major versions, features and turning points. Python began in the late 1980s, and Guido van Rossum started implementing it in December 1989 at CWI in the Netherlands. It was designed as a successor to ABC, but with stronger practical features like exception handling and the ability to interface with the Amoeba operating system. Guido remained the central decision-maker for many years, which is why the community called him the BDFL, or Benevolent Dictator for Life. And yes, the language name came from Monty Python's Flying Circus, not from the snake. The first public code for Python version 0.9.1 was published in February 1991 on alt.sources. Even at that early stage, Python already had many features we still associate with it today, including classes with inheritance, exception handling, functions, and core data types like list, dict, and str. It also had a module system, which Guido described as one of Python's major programming units. By 1994, the comp.lang.python discussion forum had formed, giving the growing community a main place to talk and collaborate. Python reached version 1.0 in January 1994. One of the biggest additions was a set of functional programming tools, Lambda, Map, Filter, and Reduce, which were contributed through community patches. As Python 1.x evolved, it also gained keyword arguments and built-in support for complex numbers, making the language more expressive. This period showed Python becoming both practical and flexible, while still keeping its clean style. After leaving CWI, Guido continued Python development at CNRI in Virginia. During this time, he also launched the CP4E initiative, which stood for Computer Programming for Everybody. The idea was to make programming more widely accessible, just like basic literacy and maths. Python fit that goal very well because its syntax was already simple and readable. So that covers the early growth of Python and how its first identity was shaped. Now that we've covered Python beginnings, let's test what we've learned so far.
Here's quiz number 1. See if you can get it right.
Question 1. What was Python originally created as a successor to? The correct answer is the ABC language. Python was started by Guido van Rossum as a successor to ABC, while adding more practical capabilities like exception handling. Question 2. Which of these features was already present in Python 0.9.1? The correct answer is classes with inheritance. Very early Python already included classes with inheritance, along with exceptions, functions, and key core data types. Question 3. Why did Python fit well with the CP4E initiative? The correct answer is, it focused on clean syntax. CP4E aimed to make programming more accessible, and Python's readable clean syntax made it a natural fit. In 2000, the Python core development team moved to beopen.com and formed the BeOpen Python Labs team. Around this time, Python 1.6 and Python 2.0 had overlapping release schedules because CNRI wanted a version summarizing work done before the team left. Python 2.0 became the only release from BeOpen before Guido and other developers moved on again. There was also an important licensing story here, because Python 1.6.1 adjusted the license to become GPL compatible after negotiations. Python 2.0, released in October 2000, was a major milestone. It introduced list comprehensions, which made many data processing tasks shorter and cleaner, and it added a garbage collector that could detect reference cycles. Soon after, Python 2.1 connected new code and documentation to the newly formed Python Software Foundation, or PSF. It also brought changes to the language specification, including support for nested scopes. Python 2.2 made Python's object model more consistent by unifying types written in C and classes written in Python into one hierarchy. It also introduced generators, which became extremely useful for efficient iteration. Then Python 2.5 added the with statement, making resource handling much cleaner through context managers. Versions 2.6 and 2.7 later helped developers prepare for Python 3 by including forward-looking features and warnings. Eventually, Python 2.7 became the last release in the entire 2.x series. In 2014, the community announced that support would end in 2020, and users were strongly encouraged to move to Python 3 as soon as possible. Support officially ended on January 1, 2020, and the final release was Python 2.7.18 in April that year. So that completes the story of the Python 2 era, from rapid feature growth to retirement. Now that we've covered Python 2 evolution, let's test what we've learned so far.
Here's quiz number 2. See if you can get it right.
Question 1. Which feature was introduced in Python 2.0? The correct answer is list comprehensions. Python 2.0 introduced list comprehensions along with cycle detecting garbage collection. Question 2. What was a major innovation in Python 2.2? The correct answer is unification of types and classes. Python 2.2 unified built-in types and Python classes into one hierarchy, making the object model more consistent. Question 3. Why was the with statement in Python 2.5 important? The correct answer is it simplified resource management. The with statement works with context managers, helping safely open files, acquire locks, and release resources automatically. Python 3.0 was released on December 3, 2008, and it marked a major reset for the language. It was intentionally backwards incompatible because the developers wanted to fix deeper design issues that could not be solved cleanly within the 2.x line. A key idea behind Python 3 was reducing duplication, so there would be fewer old and overlapping ways to do the same thing. This followed the Zen of Python idea that there should be one obvious way to do it. The move to Python 3 was powerful, but not easy. A lot of Python 2 code did not run unchanged on Python 3, and Python's dynamic typing made perfect automatic translation very difficult. The 2.3 utility helped with the parts that could be converted mechanically, and for some time developers were advised to maintain compatibility carefully across both versions. Later, the preferred approach became maintaining one code base that could run under both Python 2 and Python 3 using compatibility tools. Python 3 introduced several changes that are now considered normal by modern Python programmers. The print feature became a regular function, which made syntax cleaner and more consistent. Input handling also changed, and text support became much clearer by unifying str and Unicode into a single text type while separating bytes data. Another famous change was division. In Python 3, 5 divided by 2 gives 2.5, while float division uses the separate double slash operator. After Python 3.0, the language continued evolving through many 3.x releases, with improvements spread across performance, tooling, and long-term support. The article notes that 2.3 remained available through Python 3.12, showing how long migration support mattered. As of the article's update, Python 3.14.3 is the latest stable release, while Python 3.10 is the oldest branch still supported in the security phase. So now we have the full picture, from Python's birth to its modern maintenance model. Now that we've covered Python 3 Shift, let's test what we've learned so far.
Here's quiz number 3. See if you can get it right.
Question 1. Why was Python 3 made backwards incompatible? The correct answer is to fix design flaws cleanly. Python 3 introduced breaking changes because some core design issues could not be corrected while staying fully compatible with Python 2. Question 2. What did the 2.3 tool mainly do? The correct answer is converted some Python 2 code to Python 3. 2.3 automated the parts of migration from Python 2 to Python 3 that could be translated mechanically. Question 3. Which statement about division is correct in Python 3? The correct answer is 5 halves returns 2.5. In Python 3, normal division returns a floating point result, while floor division uses live phi. Now you've seen how Python grew from a small readable language into a modern programming standard, and hopefully you also did well on the quizzes along the way. If you enjoyed this interactive format, like, share and subscribe to Xplaquiz channel for more simple and engaging learning videos.